I have here iron-filled composite PLA, which means that there are iron filings inside this 3D filament, and that gives it the properties of iron. So what we're gonna do, we're gonna print a bunch of things on my printer and test to see if it has the properties of iron, which are being rustable, magnetic, and electrical. And maybe if it's both of those, then we can do an electromagnet that's 3D printed. Isn't this pretty cool? Composite iron PLA. For the electrical aspect, I want to see if I can basically 3D print wires with this, and maybe a mock motherboard to see if we can light a light bulb. And to test it, I have a multimeter set up, and I also have just your standard electrical wire, so we can see the difference in resistivity. We're going to soak metal-looking prints into a vinegar and salt solution, and that's going to speed up the rusting process and turn it straight into iron oxide in a couple minutes, maybe a few hours. There's one problem before we can use the iron PLA to print, and that's the fact that this nozzle won't do a good enough job. The iron filings are in there. It's going to be really abrasive on soft brass, basically going to ruin my extruder nozzle. So that's why I bought some hardened steel nozzle kit. This is for this one from Elegoo. And I also have a bigger diameter just to make sure that nothing gets clogged in the nozzle while it's coming out, because you know there's gonna be bigger chunks of iron in there. So we're gonna print with a 0.8 millimeter nozzle instead of the standard 0.4 on brass. So this has, I think it has a 0.6, a 0.8 and 3.4s in this set. If you've never taken off or replaced your extruder or nozzle, then the first thing you gotta do, or I'm just gonna show you for this part, is take off the casing. Okay, let me get some more torque. Okay, for the Neptune 3, it has just 2 screws up here. That works out. Make sure you don't drop them and lose them, or else you're cooked. Up, just like that. And now this will come off very carefully because it does have a wire connected. The fan wire here. Pull this out. There we go. We can take the silicone. There you go. The silicone casing. Just drop it somewhere on your bed that you don't lose it. You have to heat your nozzle to about 210, 205. That's going to soften the filament that I have left over in there. If you can see that, the black filament. That's actually PC, so I might have to go a little hotter. In here, it's on now. I have it set to 230. So you might need something like this to hold the heating block because it's the heating block, which means it's hot. You want to take both wrenches, or if you have pliers, those will work too. All right, if you're looking down on it, then you're going to go clockwise. If you were looking up, you'd go counterclockwise. Mine is already loose because I started a bit. I think it's starting to come out. It's definitely stripped the wrench a little bit. We're just going to keep turning, keep on twisting. I could probably do that with my hand now. Keep on turning it until it comes all the way out. There we go. We got it out. Now you can pop the new one on there. It's gonna go pop. I'm trying to be quick about it before the heat really turns up on that. Now I'm just gonna use the wrench again to tighten it. There we go. And then you got yourself a new nozzle on there. But you always want to level your bed. Re-level it after every time you change out the extruder, or you change out this entire hotbed, or whatever you change out. Always make sure that you re-level your bed, because there's going to be a slight difference in each nozzle set. Now that we have the bed leveled, we can find some objects, put on the SD card, pop it in, and print them. Obviously, for magnetism, I want to see if I can get a horseshoe magnet and try to 3D print that. It's a pretty simple design. I'll just download this off Thingiverse. Horseshoe magnet without letters. I want the letters on there. Why not? For something to rust, I want to look for something like a wrench or maybe a metal kind of tool. I think this should do fine. And of course, I'm going to use this Rusty's logo from Cars 1, 2, and 3, and 4, I think there is. But this would be a great thing to rust. I'll download that as well. Thing I want to rust is some sort of blade or knife. I think I'm just gonna go with this here, a Suma's Chakra blade. I don't know what this is from. I'm guessing an anime. If you're printing with a bigger diameter nozzle, you need to change that in your slicer settings. So we'll just go here into the settings, go to printer, manage, machine settings, and change this to a 0.8. We also have to change the printing temperature because brass is considered a very soft metal and it has a lower specific heat versus printing with steel. So we need to raise the printing temperature of the extruder by like 10 to 5 degrees Celsius. So we can just go to material and printing temperature, and instead of 200, we're just going to change that to 215 because it also says so on the box here. I've changed my layer height to 0.32, and because of that, I'm gonna drop my speed down by 30 meters a second. So instead of 60, we'll do 30. And then we're gonna lower our retraction because 2.5 is way too fast that you could clog your extruder. Let's just go with the 2. I said speed, but I meant distance. Let's go with a 2 millimeters distance. Okay, we have all our settings modified. So it's gonna be a 7-hour print in 34 minutes. So let's put the SD card, that's the wrong way. Let's put the SD card, that's the wrong way. Okay, grab my other hand, how about that? Put the SD card, that's in, perfect. I'm also gonna put glue down on my bed because I don't know how sticky this iron-filled PLA is. So we're just gonna glue everywhere. Move this out the way. And while the extruder and nozzle are heating up, so we can load this in, take a look at this. Look at that nice iron gray that it has. This is from Protoplasta. It has the same diameter as regular PLA, so I'm not expecting any problems. You can unwrap this plastic here. Wow, it has like a very like chalky, hard texture. It feels like cardboard almost. And we can pop this on. Right up here, place it through. Let's load that. That's pushing out all the past PC that I had. Now it's got that iron gray. I think we're ready to print now. Currently the next day, and the prints are done. It was an 8-hour print, so a little more than the 7 hours and 40 something minutes. Let's take these off. I noticed there was a little bit of like stringing here at the bottom on the first few layers. And for the wrench, I wasn't gonna think it was gonna come out nice because first layer was horrible, but it seems fine. I'm not gonna use the workable part for it because I'm not really here for that. I'm here for the rusting, so let's take these off. Just gonna, whoop, there we go. I think my leveling was off a little bit. This can definitely be pressed down more. You can see the lines, those are too skinny. You wanna compress flat on there, but look at that, resties. Let's take off the knife here. It feels like chalky, if that makes sense. Can't wait to rust these. And the wrench. Look at that. The back side. Yeah, you can see where it messed up a lot there. And here. It was just doing pretty bad. I'm gonna put the magnet on here, set up the time lapse. I'm also going to move my bed up or move my nozzle, level it down a little bit so that it's more compressed for the first layer. And these, I'm going to spray them with vinegar, leave some salt on it, and see what happens with the rust. Some flash rusting here. I just have some salt, and I have some vinegar, red wine vinegar. I'm going to just pour the salt up there on the blade, because I want the rust to really just be on the blade part, instead of the handle. The salt is an electrolyte, so it moves that are being taken from the iron by the vinegar much faster than regular water would.
So rusting is a chemical reaction where the iron meets with oxygen and water to form iron oxide, which is like the reddish brown flaky substance that you see. Vinegar provides the acid that speeds up electron flow, and salt is going to provide the ions that help electricity move faster. And so working together, they make the iron break down and rust much quicker, and this is called flash rusting, which is why we're using the salt and vinegar instead of regular water, because that could take days, weeks maybe, and I found this way to be a much faster way. Now you can do this with pretty much any iron object that you have around the house, like nails or coins. I actually took this red vinegar from my job.
It's been like 8 hours. I don't really see a difference. The vinegar has evaporated pretty much in the salt. I didn't mix it beforehand. So what I'm gonna do is get hydrogen peroxide instead, because that's a way stronger acid. It should speed up the process. I'm gonna spray it out of this bottle that I just bought. Oh, wow. Oh, that is instant. That's really cool. I need to put more in here because I don't have enough to spray. Guys, just found out that the spray bottle piece can actually fit on the hydrogen peroxide container. So I'm gonna just pour it straight from here. Look at that. If you can't see, it's fizzing.
I chose the red wine vinegar because it has a dark red color. So when you rust any iron with it, it comes out as a darker tone, more grimy and more rustic feeling. So that's what I was going for. Some people use like white vinegar, or I think there's some colorless vinegar, or that might just be white vinegar. But this one was just so much better. I feel like you can see how it leaks off of the prints onto the plate. You can see the color getting darker and browner in the liquid. There's a lot of fizzing. There's bubbles popping up. And it's such a difference between the vinegar with the hydrogen peroxide and without. Sometimes I had to flip them over and move them around so that I could get an even coat of the hydrogen peroxide and the rust. But over the course of a few days, I just kept spraying them on multiple layers. So while these are soaking over the course of a few days, let's jump over to how I'm printing the magnet. Time lapse cued in 3, 2, 1.
The magnet has finished with a 2 hour and 58 minute print. Let's take it off. There we go. Look at this horseshoe magnet here. South and North Pole. Shing. Now let's test it. Here I have neodymium magnets, which are one of the strongest permanent magnets in the world. They're made of an alloy of neodymium, iron, and boron. And then I have the magnet horseshoe that I printed here. So I'm gonna see if these are actually magnetic. I don't know, because the heat from the printer might have ruined its properties, because magnets are affected by heat. Let's see. No way. No way. It actually works. That's really cool. I genuinely didn't know if it was gonna work or not. Wait. So you can do some pretty cool stuff with this then. Oh, look at that, the string, the little stringing there attracted to the magnet. You see? Ooh, is this? Yeah. Look how once I get closer, it pulls it. Up. I took a chunk off. Now, iron is ferromagnetic, which means that you can make it, you can magnetize it by rubbing another magnet on top of it. But this is cool. Got the magnet rolling. This one. Oh, okay. Too fast. Let me try that again. Really cool. It's a 3D printed magnet. And the strings here, it's almost like a magnetic fiber. And they want to be attached, like a magnetic spider web. That's really cool.
You can make this a permanent magnet by using electricity or heat in the presence of an even stronger magnet and basically align these poles to how they're labeled here. I think it'd probably be as strong as one of those ceramic gray magnets that you see in like school or at work or on the back of your fridge decorations. Over the course of a few days, I've been spraying this periodically with the hydrogen peroxide and pouring some more salt on it. This is pretty much the finished product. So this is the rusty knife here. I don't remember what it was called, but it looks pretty cool. It's kind of sparkly too because the iron particles there and the salt. And then we have this, and this is the wrench here. I feel like the salt adds to the effect. It's like a crusty, rusty tool, especially that back. That has a nice brown rust. And then we have the Rusty's logo. Let's look at it. That's actually like gorgeous. Wow, put that up somewhere. That's really cool. Okay, now we can test the voltage, resistivity, whatever, electricity, shooting through these 3D prints. We're at Namit's house, the salutatorian. So we're gonna use his multimeter because I don't have one. And we're gonna see if we can blow up this house because we have a...
You're not blowing up my house.
We have a power adapter that's 24 volts and how many? 12 amps.
Yeah.
So we're gonna see if we can burn a hole through this.
Yeah, we are going
Or if we can just try to light these 3 LEDs. We're just gonna test the resistivity. So we're gonna change it to ohms. I'm gonna guess like, I'll put in like 2000 range. We have the thicker one, medium one, and the very thin one. It's very flop.
That's 2,000. It's 2 million.
That's too... No.
Wait, the resistance of the
you're
air
right. That's
is
kilo ohms.
600,000 ohms.
So this is just from my body. This is 190 up. That's the resistance of my body using the 2 leads. Put it on here. Uh-oh. This might have a lot more resistance. What if I use the clip onto the small one then? This to this. Get smaller distance. Or shorter, I should say. Maybe it's the lines. So if I have it going on the same pattern.
I mean, there's no way it's like that high.
Let me try just the regular spool. So I have just the spool here. No. That's a short distance. No way, it can't do that.
It's like, what, it's probably like 50% metal, 50% plastic.
So it's not conductive. But that doesn't mean that it won't burn. So we have to figure out if Nimit's house is working or not.
Alright.
So let's connect the multimeter to his outlet.
Alright, so we're getting 24 volts.
Yeah.
Should be 12 amps. Yeah, so this is working.
It works. So you just learned
This is getting hot, right?
you can't plug it directly into the outlet because it just won't measure anything. I think it needs to have like
Maybe it was backwards.
some kind of little...
That doesn't...
Yeah. I think it just needs to have something that's drawing power. I think this draws like this activates the outlet. You know what I mean? We're also going to do this outside just in case it does cause a fire. We're just going to cut wires for these two and then clip it on using the banana clips. So I'm just taking off the black and red wires out. So I'm just going to cut this and the red one goes in, cuts it off. Now he needs to just strip off the insulation. I don't know what gauge this is though. I think it's 14 gauge. It's not 14. I think it's... Oh, I put it in 12 by accident. I should have did this before I cut it, but that's okay. It's definitely a lot smaller than that. Was that 16?
Yeah, I screwed all the
Yeah, I should have did it before I cut it, bruh. There we go. Oh, they're like loose.
Oh yeah, it's stranded.
I really like this wire cutter. It has a, you know, as you can see, it has all the stuff. So now we can put these in here. Anytime you're working with electricity, make sure that it's all unplugged. And it also has the little screwdriver thing, so you gotta screw those down. That's what he's about to do. Okay, let's plug it in.
It's plugged in. Is there a voltage across
I'm gonna
this?
measure it. Measure that voltage.
There's 24 volts across these two.
There's a voltage against the wires, but it's not going through.
Doesn't seem to be
filament,
conducting.
actually.
It's not warm. It's room temperature. There's no signs. Okay.
Since the printed part isn't working, we're just gonna try apart from the filament. Okay, plug it in.
I will leave my dogs out in the comfort of my own home. That's my right.
Are you ready? I'm gonna plug it in 3, 2.
See if it explodes. I think there's too much plastic in it.
Guys, it's not conductive, but it is magnetic, and it is rustable. Why isn't it conductive? That's because the plastic, it is 45% iron density, or iron by weight, but the plastic encapsulates all the iron particles, which makes it a dud, and more resistive than me. So then, we were able to get a magnetic filament that actually sticks to magnets because of the iron. We were able to get Rusty 3D prints. We have the wrench here, the knife, the Rusty's logo, and they smell like vinegar. And the salt really adds that shine and glow to it, but unfortunately we weren't able to get it to be electrically conductive, and that's probably just because of the concentration of iron. You know, you can't mix too much iron because then it won't melt. You need it to melt to 3D print. But I did find out that there is a specifically electrically conductive filament, so I might try that in another video. If you learned something like I did, leave a like, leave a comment. I love you. Like, subscribe. We can all come to Nimit's house and have a house party, by the way. So I'll see you guys here.